Greetings. I'm just going to be talking about the Mothbot. This is a little radio kit that we've designed to be easy to assemble by hand. So it's a good soldering project. It's kind of fun that way. And it's a little radio node. So if you get materials for two of these, then you can communicate over significant distance, at least a couple kilometers, but if you really work at it, you can get like 100 kilometers, and people do with these sorts of radios. It is so some key things to mention about it. It All of the parts we've intended them to be both easy to solder, but also easy to source online. So these parts you can find from multiple distributors. And the circuit board, it's a custom circuit board, but the design is available online and you can order it from multiple manufacturers. And all of these parts will be around for at least a couple of years for you to buy from someplace online. Like I would say probably at least 5. Who knows? But in that sense, it's a bit different than the pre-assembled boards that you can find online that can be incredibly cheap, but you're never quite sure how long they're going to be available when they're a little pre-assembled custom board. Using the commodity parts this way and the fact that it's easy to hand assemble, so for example, the Adafruit Feather is a fantastic, it's a smaller board. It's designed to plug into a breadboard. It's great for prototyping. It allows rechargeable lithium battery. It's a really cool design, but it's using versions of these components, these resistors, capacitors, and especially the integrated circuit here that are pretty hard for beginners to solder. Like, I don't think you can even make out in the video the individual pins around this integrated circuit. These are really designed to be assembled by robots, which is great because then you can pump out a lot of them and make them really cheap. But the downside is if you don't have one of those fancy robots, which can be pretty expensive, then you have to kind of rely on another entity to kind of make these for you. So you can think of this as kind of something like this board simplified, exploded into its constituent pieces, and then using the versions of those pieces, the resistors. I mean, again, I don't know if you can see, but there's some resistors, I think, here on the board, like 1, 2, you can barely see them, as opposed to resistors like this, where macroscopic, you can handle this, you can solder that. Even if you're a beginner, you can probably do this on your first go. So yeah, those are the main ideas. And then also we're using, as the basis for this board, the same integrated circuit chip that controls the Arduino Uno, which is an incredibly popular hobby electronics platform with thousands and thousands of tutorials online available for it. So if you want to do anything custom with this board, you already have, we're leveraging a big universe of pedagogical material that's already online for you to use. The LoRa radio that we're using is kind of a hip radio that's come out in the last couple of years, really widely deployed, so that's probably going to be around for quite a while. So it's both like kind of more or less the latest and greatest, and it's got these nice features around being low power and long range. But it's also got staying power. It's got legs, and it's something that you could rely on. So the idea is it's a nice project to learn how to solder and produce something that's kind of fun to use, or radio communication where you can communicate over long distances. It's also intended to be very functional. So if it is something that you decide you want to use as local infrastructure to monitor temperature in a greenhouse, or flood as a flood monitor, measuring water level, it's designed to be pretty easy to do that. So that's another thing where The Feather is just great for general prototyping, plugs into a breadboard. And then there are boards that you can plug it into that allow you to connect it to other boards with screw terminals and so on. We're kind of really dialing this down into digging into, drilling down into, I don't know. But anyway, we're specifically targeting some field environmental monitoring applications. So instead of all the pins being broken out, like on the Feather, where you see many pins along the side here that could connect to many different types of things and multiple versions of those things, and many pins here on the Arduino Uno. If you wanted to deploy those systems out in the field, you really kind of have to do a bunch of tweaks to kind of curate it all to connect to the sensors you want. Here, oops, my video setup. Here we've got places for a couple screw terminals that really dial in specific temperature and humidity sensors that are easy to find online. They're cheap, they're effective. We like how they perform, and so we've made specific choices around that. Temperature, humidity, and ways of connecting over serial to water level devices or GPS. So what else to say? I think that's it. Yeah, so the assembled board, when you solder all this together, here's what it looks like again. And it's cute. It's got some mounting holes so you can mount it on a surface. We're figuring out how to do mesh networking with it, so that's going to be really fun to play with. You use just like a standard soldering iron to solder all the things. I'll be describing how to connect it to sensors, how to assemble it, how to program it for basic things in other videos. But this is just to serve as a quick intro, because we just got the boards in yesterday, and I built the first one. This is the only one that's ever been built, and it worked, and it's really exciting. And I got it to talk to a Feather board, so that was cool. The other thing to mention is, unlike the Arduino Uno, which can talk directly to a laptop, and the way it does that is this chip talks to a USB to serial converter. So the serial that comes out of this, which is a protocol, talks to USB, which is the protocol that we all know and love. And then you connect a USB cable here, and that talks to your laptop, and your laptop is how you program the board. So if you've ever played with an Uno, you know all this. The same goes for an Adafruit Feather. For an Adafruit Feather, the same chip that is the brain of the board also happens to be able to talk to USB directly. So that's nice. But in our case, we decided not to put the USB serial converter on the board. Because it was difficult to find one that is easy to solder, so it kind of changes the nature of the kit, and also because really the USB to serial breakout boards themselves are pretty reliable commodity components that you can get for $5 or less. So you'll see that this has a micro USB port on it. And when you want to program that, so you buy one of these, and then for however many boards you have here, you just reuse the same programming chip, and you plug that in, and then you connect this to your laptop via USB cable, and that's how you program this. This header can optionally be a right angle header, so it's bent down. That might be another configuration of the board, but I didn't have any right angle headers at the time. The basic configuration of the board, just all these parts, you assemble it, you get a radio, and you get to experiment with that. And then there are other sensors that again we'll describe soon. And that is pretty much it, I think. Stay tuned for more. Exciting times. The beginning of this Mothbot project. Woohoo!